At this
Sure.
point, I think I want to invite all of the speakers back up on camera, and we'll kind of switch over to a more general QA and discussion until we are out of time. So thank you. Everybody come back on. There's been a bunch of questions that have come in over the chat and the Q&A area. And I'll toss it out there. It might prompt somebody, but definitely as you guys are answering, like interrupt each other, talk to each other, build off of each other's answers. These kinds of things are best when there's a discussion, and you guys are all amazing and have presented amazing information. So let's go. The first one, which I loved, for students, including grad students who are interested in the intersection of AI and VFX, what should they study? What kind of experience should they get to get a job? Any advice for those folks?
Linear algebra.
Anything you'd recommend playing around with?
Yeah, look, I would sort of counter that, Doug. I would say that your linear algebra is great, and that, you know, the more math that you have, the better off you are. But I think there's a possibility to work with machine learning at a sort of intuitive level as well, that you can sort of sit there and say, look, I've got ground truth and I've got data, and I want to smush this stuff together in a roundabout way. And I think that you can really be useful in that capacity of pruning data sets and getting intuitively able to understand about how things are generalized and how they're overfitted, and do all these sort of things in a sort of parochial way without having to get into the ones and zeros. But at the end of the day, you know, with my little, you know, hearts from 1995, if I didn't understand how a Phong roughness coefficient worked, there's no way I can make the combi vents. Do you understand what I mean? So you've got to be operating at sort of both levels at the same time and be able to go big and small with your ideas.
Agreed. I do agree. And machine learning right now is amazing, but also it's changing so fast. There are so many papers, so much interesting research coming out so quickly. And a little bit of linear algebra gets you a very, very long way into understanding what some of these papers actually mean. So the best thing of all is, like I said, a lot of this code is online. If you see a paper and you're like, whoa, is that going to work for me? You can go to GitHub or Google Colab and just press run until it runs. It's surprising. You don't even need a computer because Google is providing all the computers. But at the end of the day, you really need to understand it's all vectors and matrices, quite frankly, and you just need to know have a little bit of familiarity. Otherwise, it's going to be this black box that is going to remain a black box. And yeah, you just need a little bit of linear algebra.
No, you actually, Doug, you're dead right. You can't get away from it. You know, like at the end of the day, maths and BAS and computers are computers, and you do have to get along with both of them. It's, you know, the same as a painter back in the Renaissance period was mixing their own pigments for making their own paints. They're the ones that were actually the great artists, and it's actually being able to get in contact with your medium and understand how it all works. And, you know, I'm sitting there talking about the amount of memory on a video card. People don't care. They just want to have the magical things, but you do have to care that if the experiment that's been running for 36 hours runs out with an out of memory error, then it's game over, dude. You know, like it's so you do have to be aware of your medium. But I think the other thing is Papers with Code is another wonderful resource where it will talk about what's state of the art for a particular model and you can jump in and read the paper and see the pictures, and then jump in and grab a demo, grab a notebook on Google Colab and go next, done. And then you can start tinkering. Then you can sit there and go, what if I changed this input here? What if I fed in my own data set? What if I did that? And that's actually what I responded with there. And I said PyTorch, but I don't really care between PyTorch and TensorFlow. It doesn't matter. But if you can get on there and get jamming, and you don't have to go out and buy a $3,000 GPU, you can sit there and jam on things with some YouTube videos of some, basic linear algebra system, and you can get there with a Google Colab, and you can just start chomping. And then when you're finding that the Google Colabs are booting you out because you're using too much GPU time, then get some investors behind you and get some Amazon Workstation time and light it up, because there's an opportunity here to be jamming on things that are much bigger than your little laptop's gonna get its way through. But like the concept of label data, linear algebra, and a little bit of Python chops, and you're golden.
I will caution people, though, just a little aside, since you mentioned that. You think, oh, I'll just go to the cloud and I'll start training on the cloud. This can get really expensive really fast because you get addicted to this stuff, right? You want a computer with a good graphics card so you don't have to wait 16 days in order to see the results. And so you go, well, I'll just click on this thing that has 4 GB100s in it. And then all of a sudden the cost just goes, what is going on? So be careful.
I did say get an investor too. Yeah.
And always choose that interruptible so that Google can kick you out when they want to, because it lowers the cost a ton.
Yeah, save checkpoints as you go and you'll be good.
Nice. All right. So there was another set of questions that were all kind of about the same thing. So this person who's playing around with all this stuff, they're in school, they're graduating in 5 years. What will VFX look like? Will any of this stuff change the workflows that we know?
I know personally that human character animation will be done in a completely different way. It's starting to happen, but building high-res meshes of things, yeah, I think that's going to be gone. You probably will have high-res meshes of environments, but high-res meshes of characters, I think rather, especially for humans, where there's a lot of available data, you'll just train it. You'll just train something and build something that's extremely low resolution and let the renderer just fill in all the detail. 5 years? Yeah, totally. Yeah, that'll be done.
The evolution of what Ting was showing.
Yeah.
Nice.
So much stuff is going to be done based on data. It's, yeah.
I'll just chime in and say that like the interesting thing is too, just the order of things, because virtual production is definitely a big buzzword right now, but just the fact that it's now requiring a lot of things to be done in pre-production that the assets carry over to post. I just feel like everything's kind of jumbling around right now, which is kind of exciting, because as much as there's been so many innovations over the last 25 years, in a lot of ways, they just kind of piggyback on each other, and there hasn't really been that major disruption. And I feel like right now is the perfect storm of everything where, yeah, I think 5 years from now is going to be exciting just to see how kind of different we look at things to how we have been doing things so far.
I've got some sage advice. I would look at the things that will never change, right? So you've got to be able to communicate really well. You've got to be able to tell a story really well. You've got to read what comes into the camera and ends up in your heart. So films are about making an emotional response. If you can tune in to what makes the emotional response and then pick the right tool set to do that, you'll be good at being able to pick the right tool set and be able to learn. And then learning from past masters, looking at all of these old films, looking at, how they were done, see if you can meet people in the industry that have been there and done that, and learn, just constantly keep filling the tank with the history that's gone before. And then you might be able to see a little bit further down the road about what's coming next. I think the answer to the future always lies in the past.
Well said.
And I agree. And the one other thing is the thing that won't change is the need for artists. Artists are going to be a constant. These things that we're building are all just tools. And as you know, the tools, as they get more and more complicated, are just as hard to use. And yeah, artists we're going to need just as many artists. They'll just be doing different things.
So, I mean, that kind of dovetails with another theme of questions that were coming up in terms of the results of these systems. Any thoughts to how we could make them more art directable, or how we could make the outputs of them kind of well suited for handoff to downstream artists? We do a lot of stuff in our work in order to make life easier for the people we hand our work off to. But, you know, how to build those kinds of things into ML-based systems.
Well, that is one of the hot research topics of this year. And a super geeky buzzword here, latent space disentangling, or disentangling your latent space. And I'm not even going to explain this, but what this means is the machine learning has this well, I'm going to explain it, because machine learning has various representations of stuff in its pipeline. And at its core level, there's what they refer to as latent space, where you basically have this vector that describes what's going on. Undecipherable. It's just this a list of numbers, but everything that you want to know about the process is in there somewhere. And so this disentangling is teasing out the information that you want to know. And once you've done it, being able to change that information and put it back into this thing. So it's basically cracking open the machine learning, figuring out what's going on, and building tools to change it. And we are working on this all the time. It's because exactly that. Machine learning is brilliant, but input and you get what it's on the output. And artists want to say, no, that's not what I want. I want this. And it's in there. We just need to have a lever to be able to change it.
Yeah, Doug, I've got an example of that. We had a tool at Rising Sun Pictures, which was trying to get rid of neg scratches back in the day when we were shooting on film. And you find that if you go from screen space, you go to an FFT space, is the scratch will stand out like a little dot. And then you just smudge over it in FFT space, and then you go back the other way, and the scratch magically disappears, right? So this disentanglement, or attention is another word for it. And if you can actually reduce it to me just going dab on that thing, and that scratch is removed, compared to sitting there doing paint fixes on 500 hours of scratches, then you are making money. You're making people happy. You're giving them entertainment time. You're reaching this digital utopia that we're all about. And at the moment, what we're stuck in is we're stuck in this cycle of heat. We're just throwing more compute at it. We're throwing more data at it. And if you can actually get to the attention space, and the idea that I came up with before is the Pareto principle of 80-20. You do 20% of the time to get to 80% of the quality, and then the remaining 20% of the quality takes 80% of the time. If we can do that with machine learning, that we actually get to the 80% of the way there, and then we just keep on nudging that Pareto principle, so that we're actually only having to do 1% of the work, and the reinforcement learning comes back. So we give the computer an 8 out of 10 and tell it what the 10 out of 10 answer is, and it learns and gets smarter and gives closer and closer to 10 out of 10. That's really what's good stuff. And I hope that people are working towards that goal, where it's not just a one-shot dice roll. Did I roll a 6? I'm going to roll again until I get a 6. That you actually roll it and you say 6 plus 2 or 4 plus 2, and we've got a 6. And then we're having to add on less and less each time. And then we're just rolling 6s all the time.
Awesome. All right. I hate to say it. I feel like I was just getting rolling and I've got 2 pages of questions over here, but we are running out of time and we've got to make sure Sunil has time for some closing remarks. So I just want to say thank you to all the speakers. This was incredibly, incredibly fun, enlightening, illuminating. So Sunil, over to you.
That was such a great discussion. I just knew that if I just got all of you guys into one room together, there would be like this magic. And I feel almost bad to have to like end it, but we do have to end. Yeah, we probably need to get you guys all back again some other time. So thanks again,
the figure of late night session with beers and alcohol.
Yeah, oh yeah, definitely, yeah. Thanks again to everyone for coming to this LA SIGGRAPH event. And of course, a special thanks to all of our great speakers. Yes. And the many people behind the scenes that make an event like this possible. This event was recorded and it will be available on our chapter's YouTube channel, which is listed on our website. And we have a lot of other great events coming up. Our next event is our Meet the Startups, which will be on January the 12th. And in February, we have a joint event with a group called Girls Who Code. And they're presenting coding, graphics, and interactive techniques. Then in March, our annual Careers in Digital Media events. And in April, events in the metaverse, as well as in May, VR and medical. So lots of great events coming up. So have a great holiday season, everyone, and see you in the new year.